Hello everyone, welcome to Cloud Ops Craft. Today we are going to discuss about Git and GitHub for DevOps. That everything you need to know. Okay. So first, what is version control? Any idea? If you have any idea, just stop this video and let me know on the comment section so I can understand uh, your perspective or your way of explanation. Okay. What is version control system? Why it matters? Imagine writing a book with five friends, but no one tracks changes. Then how it will be? That's what happens in software teams without version control. Okay. Git is like Google Docs for your code. It will track changes, and you can collaborate and you can roll back safely. Okay. While coming to real world DevOps angle, infrastructure engineers store Terraform code in Git to manage changes and review updates through pull requests, just like developers. Okay. Without Git, confusion will be there. With Git, you can track, revert, collaborate, audit. Okay. So with the Git, what you can do, you can track, you can revert, you can collaborate and audit. Okay. What is Git? The engine of modern DevOps. The thing is, Git is a distributed version control system, okay, which is created by Linus. Okay, uh, why Git is called as distributed version control system? Any idea why Git is called as distributed version control system? Before that, okay, before understanding this, you need to know what is centralized version control system versus distributed version control system. Okay, example for centralized version control is subversion SVN. Okay, where you will have one central server that stores the whole repository. Developers get only the latest snapshot of the code. If the server is down, no commits can be made. Okay, centralized VCS CVA, like CVCS is like a single library. Okay, you can only read if the library is open, which means if server is up and running, then you can able to work with it. If server is down, you can't do anything. Okay? Which is centralized version control system. While coming to distributed version control system, okay, it's like example tool is Git and Mercurial and all will come under distributed version control system only. Every developer machine has a full copy of entire repository, including history. Okay, developers can commit, merge, branch, and view history offline. Okay, here the central server is GitHub. Okay, GitHub is the web hosting platform. Okay, it's mainly for syncing and collaboration, not for storing the only copy of the code. For example, every student has a full textbook. You can study, highlight, and make notes even if the library is closed. Right? So, example tool for DVCS is Git. Okay. How Git works as a DVCS? The thing is, when you clone a repo, you don't just download the latest files. You will download the entire history, branches, and metadata. What you can do? What you can do? You can make commits, you can create branches, and you can compare difference. Okay, and you can roll back to older versions. all without being connected to the internet. Pushing and pulling to the remote is only needed when sharing with others. Okay. What is the benefits of Git being distributed? Benefits of Git as a distributed version control system. First feature is offline work. Okay. While coming to centralized version control system, you cannot commit without internet. Without internet, you cannot commit. But in distributed VCS, you can here full history available. For commit, you no need internet connection. Second is performance. Okay. So while coming to centralized version control system, server round trips. Okay. Here you have to maintain your server. If there is an issue with your server, then you can't do any operations. Okay. While coming to distributed version control system, everything you will do locally. It's all about local operations. Only for pushing your code. Okay. Why you have to push your code? So only you can collaborate with your team. Okay. So we will use GitHub is just a web hosting platform where you can host your Git repositories. Okay. Next is data redundancy. Okay. Here in CVS's major drawback is single point of failure. Okay, while coming to distributed version control system, every clone is a full backup. Okay, so this is the benefits of Git being distributed as well as collaboration. Okay, another advantage is benefit is collaboration. Okay, here you will have server bottleneck. Okay, but while coming to DVCS, here it is a peer-to-peer. Peer-to-peer is possible. Next is branching and merging. It is very expensive. Okay, in CVCS, centralized version control system. While coming to distributed version control system, it is lightweight and easy. Okay, centralized version control system is like a one master diary in a classroom. If it is locked in the teacher's desk, nobody can write notes. Okay. Second is distributed version control system, which is Git. Every student has a full copy of the diary. You can write, erase, or review history on your own and sync with the classmates later. Okay. It is called as a distributed version control system because every clone contains the entire code base and its history, allowing developers to work independently and offline and eliminating the single point of centralized system. Okay. And you need to know the difference between history and working copy. Okay. In centralized version control system, when you do a checkout, okay, for example, if you're doing SVN checkout, you get the latest snapshot, which is working copy of files. You do not get the full history of the project. Okay. So The history, who changed what, when, why is the only located on the central server. If the server is down, you can edit files locally, but you can't commit or view logs or branch properly. Okay, your machine has files, but not the database of changes. But while coming to distributed version control system, when you do a clone, git clone operation, you will get the entire repository, including full commit history, all branches, all tags, and complete metadata. The whole project history is now on local. If, if the remote GitHub is down, for example, you can still commit, branch, merge, view logs, and even recover history. Okay. While coming to syncer, push and pull happens later when the remote is back. Okay. Your machine will have a complete backup of the repository. Okay, and one more thing, while coming to checking your logs offline in SVN, okay, it requires server access, history not stored locally. But in Git, okay, it works offline because history is local. Okay, so while coming to CVCS, it's like you borrow you borrow the latest edition of the library book. In a distributed version control system, which is Git, it's like a photocopy of the entire series of editions. Okay, you can study past, present, and future versions without returning to the library. Okay, this is how you can compare. The main reason Git is called distributed is it's not that you get a copy of the code. Okay, CVCS also gives you that, but that you get a complete copy of the project. Okay, project's entire history and metadata, making your local clone as a full-fledged repository and independent of server. Then you can ask who maintains the repository. Okay, while coming to SVS versus Git. Okay, while coming to centralized version control system, okay, SVN, here there will be only one central server, stores the repository, code plus history. Okay, developers get a working copy from the server. Okay, so while they are doing commit, they must talk to the server. While they are viewing history, they must talk to the server. While creating branches and tags, again they must talk to the server. So the server must always be maintained. Okay, backups, uptime, scaling, everything. If the SVN server is down, nobody can commit or see logs. Okay, your maintenance is mandatory in SVN. While coming to distributed VCS, which is Git, every developer machine has a complete clone. Okay, code plus full history. The remote, whether it may be a GitHub or GitLab or Bitbucket, etc., is used mainly for collaboration and syncing. Okay, these are all web hosting platform for your Git repositories. If GitHub is down, you can still commit, branch, view history, and roll back locally. Okay, maintenance of the central remote is optional. Teams often use platform like GitHub, GitLab, so they don't maintain servers themselves. You don't have to maintain a central server unless you want private hosting. Okay, so what is GitHub? You may have this question, right? I already said GitHub is like a web hosting platform for your uh, Git repositories, but we will discuss in depth. Okay, it's like a social platform for your code. Okay, Git is the engine. Okay, GitHub is the carriage where teams collaborate. GitHub hosts your Git repositories in the cloud. You can share, fork, review, and deploy code directly from GitHub. Briefly compare Like if you want, I'll compare GitHub versus GitLab versus Gitbucket also in next video. Okay, all are web hosting platforms only for your Git repositories. Okay, for example, okay, real world DevOps example, CI/CD pipelines trigger automatically when a pull request is merged in GitHub. Okay, Jenkins, it may be a GitHub, Jenkins or GitHub Actions or Argo CD kicks in. Okay, so based on that you can configure. Okay, well, coming to Git branching, how DevOps team work simultaneously. Okay, Git branching. Now we will discuss about Git branching. Okay, imagine a team working on different car parts without messing up the master blueprint. That's what Git branches are for. Okay? Each team works in isolation. Okay, so while coming to branches, you can use main or prod branches for stable code. Okay, you can use develop a branch for integrating features. Okay, login UI, bug fix. Okay, if there is issue with the DB time mode, you can create one branch and you can fix it. Okay, once your reviewer is approved, then they will merge your code into the main repo. Okay, tools that rely on branching: Jenkins plus Git plugin, Argo CD syncs from specific branches. GitOps like Flex CD, Argo CD only monitors main branches for live clusters. Okay. Next section is pull request and code reviews. In GitHub, we will call this as a pull request. Okay. In GitLab, we will call this as a merge request. Okay. Operation will be same. Only name only will differ. Okay. We will use pull request and code reviews for collaboration in DevOps. Okay. Before you make changes, you open a pull request, which is PR. It's like raising a change request in ITI, ITIL. Okay. Others view your code, suggest changes, and only then it gets merged. Okay. While coming to DevOps practice tip, use branch protection rules in GitHub so no code gets into main unless it's review plus a CI passes. Okay. So the process will be dev will code and they will raise pull request. Okay. CI will run. Okay. And once reviewers approved, it will be merged. Okay. Next is, as a DevOps engineer, you need to know Git and GitHub in CI/CD. Okay, every time code is pushed to GitHub, DevOps tools listen. Okay, DevOps like a GitHub Actions or Jenkins can run test, build Docker images, and deploy to AWS. Okay, AWS Kubernetes. If you are like with EKS. Okay, if you are using Kubernetes in AWS, then you will use EKS, right? So you can deploy that to EKS. Okay, real world example is Dev pushes Elm chart to GitHub. Argo CD auto syncs and deploys to UKS. This is how in real time we will implement. Okay, so when git push happens, once git push is happens, GitHub actions or Jenkins, okay, will trigger and it will build Docker build to ECR Elm to KTS. We will discuss all these like ideologies in upcoming classes. Here we are just like learning overview of it. Okay, GitHub for infrastructure as code. Okay, it's not just app dev. Okay, infra is code now. Okay, Terraform, Ansible, M charts are all live in GitHub only nowadays. Okay, Teams uses Git to track changes to AWS S3 buckets, Kubernetes manifest, DNS entries with Route 53. So DevOps practice while coming to GitOps is while coming to GitOps, Git plus infra plus auto deploy. Okay, it will while coming to GitHubs and all, Git will act as a single source of truth. Okay, okay. While coming to final tips and DevOps career angle, learn Git deeply. It's your daily bread as a DevOps engineer. Okay, every DevOps project, Kubernetes or Terraform or CI/CD starts and ends with Git. Git used to PRs, branching, and using GitHub as a single source of truth. Okay. If Linux is the operating system of the cloud, then Git is the nervous system of the DevOps. Master it, and you master the flow of modern engineering. Okay, so I'll create a separate playlist for GitHub. So after this Cloud Ops bootcamp series, I'll create a separate playlist for Git and GitHub where we will learn all the operations practically. Okay, so we'll become very good in Git and GitHub. If you found this breakdown helpful, let me know in the comments. Subscribe to Cloud Ops Craft. We simplify DevOps, cloud, and core computing concepts every week. Thank you.